Today we're going to factor the greatest common factor out of quadratics, and we're going to factor quadratic functions with an a term of 1. Factoring the greatest common factor. Now we covered this in more detail back in General Math Review number 3, so you can review that. But just as a quick review, first we need to find the prime factorization of each number. So we're going to find the prime factorization of 6x cubed. 6 breaks into 2 times 3, and x cubed breaks into x times x times x. Next, 3x squared. 3 times 1, we don't have to write the 1, and then x squared is just x times x. Now we're going to compare the prime factorizations. We have 3's in common, we have one x in common, and we have another x in common. Now we simply bring down the common factors and multiply them. 3 times x, that gives me 3x squared. 3x squared will be my greatest common factor. Now, in order to take out the greatest common factor, I'm going to divide the whole thing by that 3x squared. Whenever you divide or simplify, whatever you're dividing by goes in front of the parentheses, and then you just go down the line. 6 divided by 3 is 2. X cubed divided by x squared is an x. 3x squared divided by 3x squared cancels out, but there's still a plus and a 1. And that would be factoring by the greatest common factor. Now here we have a trinomial, and we're going to again take out the greatest common factor. Do I expect you to make that table every time? No, of course not. I expect you to be able to start to do this in your head. You should see that there's a 4 inside of the 8, a 4 there, and a 4 inside of the 16. So the largest number we can take out is a 4. Now we look at the variables. I have an x3, an x2, and just a regular x. So the largest x that I can take out is just a simple x. My greatest common factor is 4x. Now I divide everything by that greatest common factor. Whenever I'm reducing, I always put the greatest common factor in front, and we divide all the way down. That'll give me 2x squared minus x minus 4. Now, if factoring is dividing, the opposite of dividing is multiplying. So before we get into factoring these trinomials, let's start by multiplying one out. If you have x minus 4 times x minus 3, first we multiply. X minus 4 times x minus 3. I'm multiplying just like we did in elementary school, on top of each other. The first thing we multiply is negative 3 times negative 4 to give me a positive 12. And then we multiply across. Negative 3 times x gives me negative 3x. We always put a placeholder in, and then we move on. X times negative 4 is negative 4x, and x times x is x squared. Last step is to combine like terms. Positive 12, negative 7x, and x squared. What I want you to see here is that the ends, the negative 4 and the negative 3, multiplied to give you 12, and then they added to give you the negative 7. This is factoring backwards. They gave us the factors, and we multiply them to get the trinomial. That means if I'm over here and I need to factor x squared minus 7x plus 12, well, what two numbers multiply to positive 12? I know that a 4 and a 3 multiply to 12, and what two numbers add up to negative 7? A negative 4 and the negative 3. So realize that multiplying and factoring are opposites, which is one good way of being able to check your answers. Now as we go through this, I want you to notice something. We're going to go through some specific examples regarding the positives and negatives. This one is plus plus. The next example will be negative positive. The next one will be positive negative, and the final example will be negative negative. So take notes on how the negative signs will affect your answers. To start with, we always start by building our houses. Now, if everything in here is positive, I can go ahead and throw in my plus signs. What two letters multiply to x squared? Well, x times x multiplies to x squared. Now I need to figure out what two numbers multiply to 36 but add to 12. In order to do that, we need to know the factors of 36. The factors of 36 are listed. Now they all multiply to 36, but which ones add to 12? This gives me 37. If I add these, I get 20. If I add those, I get 15. If I add those, I get 13. And if I add these, I get 12. So I know my answer is 6 times 6, because 6 times 6 multiply to 36, but add to 12. Now here's a hint. Always start with the numbers that are most similar to each other, 6 times 6. Then you can work your way to the more different numbers, because your answer is probably going to be close to the middle. So my two factors are x plus 6 times x plus 6. Now because they're identical, I can rewrite this as x plus 6 squared, and that will be my answer. Now for the next problem, I have x squared minus 17x plus 72. First, I start by building my houses. Again, I have x times x. Now, remember, the two n terms have to multiply to get a positive 72. There's two ways of doing this. We can multiply a positive times a positive, or we can multiply a negative times a negative. Because my middle term is negative and my n term is positive, I know I have two negatives. The next question is, what factors of 72 will add to 17? Now again, I don't expect you to write the entire table. Simply think what two numbers will add up. Like I said above, always start with the two numbers that are closest to each other. Well, I know that 9 times 8 is equal to 72. So I check 9 plus 8 is equal to 17. That works. I put a 9 here and an 8 there. Negative 9 times negative 8 gives me a positive 72. Negative 9 minus negative 8 gives me that negative 17x. And we are finished. Now the next two problems are going to have negative c terms. So we need to figure out how the positive and the negative b terms affect it. We always start the same way, by building our houses. Now, in order to have a negative number at the end, that means we've multiplied a positive times a negative. The x squared still come in as x times x. Now I need to figure out two numbers that multiply to negative 24, but subtract to 5. The reason why we're doing subtraction now is because we have one positive and one negative. So again, if I go through the factors of 24, 3 times 8, 4 times 6, and then some other numbers also. We'll start with these two. 3 times 8 is equal to 24. 4 times 6 is equal to 24. But 3 minus 8 is only negative 5, and 4 minus 6 is equal to negative 2. So I know what I need, 3 and 8, because 3 and 8 will multiply to 24, and when I subtract, I get 5. Now here's the trick. If your middle number is positive, like ours is, then you want your bigger number to be positive. Again, middle number positive, bigger number positive. So I put the 8 where the plus sign is, and I put the 3 where the minus sign is. For the next problem, again, I have a negative at the end. So that means when I build my houses, I'm going to have a plus and a minus. Again, I have an x and an x. So I'll need to figure out what two numbers multiply to 28 but subtract to 3. We know that 7 times 4 is equal to 28, but 7 minus 4 is equal to 3. So there we go. I have 7 and 4. Now, because my middle number is negative, that means I need my bigger number to be negative. Middle number negative, bigger number negative. So I put the 7 there, and we put the 4 with the positive. We can always check. 4 times negative 7 is negative 28, and then 4 minus 7 is negative 3. So we have our answer. Now, if possible, we will always check for a greatest common factor before we start this factoring process. Here I have an x cubed, an x squared, and an x. So I know I can take out my GCF of x before I start any other factoring. The x comes in front, and then we simply write what's left over. x squared minus 18x plus 81. Now I can try to factor the inside. The x, our GCF, stays in front. Because the end is positive, I know that I'm going to have a negative and a negative with an x and an x in front. Now, what two numbers multiply to 81 but add up to 18? Well, 9 times 9 is equal to 81, and negative 9 minus 9 is equal to negative 18. So I have a set of 9s. Now, because these factors are identical, I can rewrite it. Always make sure you write your answer in simplest form. Now, if you're given a problem with a negative x squared, where your a term here is a negative, then we start by taking out a GCF of negative 1. Remember, your GCF always goes in front, and then you rewrite whatever's left over. X squared minus 20x plus 19. We switch the signs all the way down because the GCF affects every single term. The GCF stays in front. We build our houses. Because the end is positive but the middle is negative, again, I have two negative signs. And what two numbers multiply to 19 but add up to 20? That one's pretty easy. The only factors that will work are 1 and 19. Now, the difference of two squares is a special way of factoring quadratic equations. They are the easiest factoring that you'll ever do. You simply take the square roots and write a positive and a negative. So we have x squared minus 9. Build our two houses, write a positive and a negative. We have an x, and a 3, and a 3. The square root of x squared is simply x, and the square root of 9 is equal to plus or minus 3. It's a difference of squares. So notice, x squared is a perfect square, 9 is a perfect square, and here's the big one where people get messed up. There's a subtraction sign. That's what it means by difference. Difference is subtracting. So this one looks like it may be a difference of two squares, but we always have to remember, factor out the GCF first. So I take out the 4 out of the front, and that means I'm going to have a 4 parenthesis w squared minus 81. Now it's obvious. W squared is a perfect square, 81 is a perfect square, and I have a difference in front. So the 4, your GCF, always stays in front. Now that I have a difference of two squares, I build two houses, put a plus and a minus. The square root of w squared is w. The square root of 81 is 9. One last one. Is this a difference of two squares? Well, let's see. The square root of 1 is equal to 1, plus or minus. The square root of x to the 8th power is equal to x to the 4th power. So, yes, it is a difference of two squares. I set it up like I normally would. I have an x, a plus, a minus, the 1, the 1. But the square root of x to the 8th is 4. So I put a 4 and a 4. Now, x to the 4th minus 1. Well, we already know 1's a perfect square. X to the 4th, because it's an even exponent, is also a perfect square. So that can be broken up. Plus, minus, the square root of x to the 4th power is equal to x squared. Am I finished? No. X squared minus 1. X squared is a perfect square, 1's a perfect square, and that's still a difference. So we do it again. Now I look at all of the pieces. I have x to the 4th plus 1. Why didn't I break this up? Because it says plus. It's not a difference, it's a sum. And then I used, or I broke up this piece, so I'm no longer using it. Then I had x squared plus 1 and x squared minus 1. Again, x squared plus 1 is a sum, so it stays the same, but the x squared minus 1 got broken up into x plus 1 and x minus 1. So when I write my final answer, I have to write all the pieces that I have.